The word ace has many meanings. It's a playing card, an exceptional fighter pilot, or the best starting pitcher on a baseball team. In the weather business, we have ACE2. It's an acronym that gets mentioned a lot this time of year. ACE stands for Accumulated Cyclone Energy. It's used by NOAA to measure tropical activity. Cyclone refers to tropical storms and hurricanes. Energy implies intensity. We use wind speed as our gauge, while accumulated means we add the energy up over the life of the storm. As an example, let's compute the ACE for a fictional storm. We'll call it Dave, that only lasted a day and a half. I made up some reasonable maximum sustained winds for Dave in knots every 6 hours over the life of the storm. Now, to compute the ACE, you square the wind speed at each time. The squaring gives more weight to faster winds. Then you sum all the answers. So the longer a storm lasts, the bigger its ACE. The total can get pretty large for a strong and long-lasting hurricane, so NOAA divides by 10,000 to get the official ACE, which would be about 3 in this case. By adding up the ACE of all storms in a season, you get a good sense for how busy the tropics have been. So let's look at this year so far in the Atlantic. 9 named storms. The average to this point is 8. So at least by that measure, it's been a typical hurricane season. But the ACE so far in the Atlantic is way below average to this point. 28 compared to 73, less than 40% of normal. That's more representative of the character of this hurricane season than the number of storms. Now let's do the same for the Central and Eastern Pacific, where the number of named storms so far is 18, well above average. And those storms in general have lasted longer and been stronger, so the ACE there is almost double the average to this point in the season. Helping to drive that tropical activity in the Pacific is unusually warm ocean water, in part due to El Nino. The maroons and oranges you see here near the equator represent water that's 4 to 8 degrees warmer than average. As for the impact on the atmosphere, well, first, you get more thunderstorms than average over those relatively warm waters. And all that fast rising air eventually energizes the upper-level winds. Then they cross Central America and spread over into the Caribbean, which is a typical hotbed for Atlantic tropical development. Now, those speedy high-altitude winds are poison for tropical systems. They make it hard for thunderstorms to organize around one center, which is a necessary step to get a hurricane. In fact, if we draw a box around the Caribbean, only 2 storms have been observed this year in that box, and both fell apart there. One way to measure the impact of strong winds aloft is to compute the change in wind speed between, say, 5 and 40,000 feet in the atmosphere. We call this difference wind shear. Here's a look at the wind shear averaged from June to September for every year since 1979. Now, the higher the bar, the greater the shear, and the less likely to get a storm in the Caribbean. The value this year is the largest in this period, consistent with the lack of tropical activity in the Caribbean. Turns out it would have been a good September to take advantage of those typically discounted cruise tickets to the Caribbean. Fred is back next with the extended forecast.